Hello everyone, and welcome to Algebra World. My name is Paul, and today we're going to go ahead and learn a little bit about graphs. Now, when I say graphs, I don't mean like you may have done in 7th or 8th grade, graphing out a function on a Cartesian plane. Now, what I mean is a set of vertices or nodes and edges that connect them. This is a very simple graph containing two nodes and one edge. Now you can add more to this, and you can make your graphs much more complex. You can even make them directional. You can say that this node, we'll call this node A, is pointed to by this one, node. I am not an artist. By this one, node B. You can also say, well, node A points at itself. Node B does not. There's all sorts of things that you could do if you have a need for it. Now, what we're going to do today is God, I hate this thing. Haha! I am a genius. What we're going to do today is create a simple graph in JavaScript. We're going to start by creating a class object, and, well, since I am oh so creative, I'm just going to call it graph. Inside of our graph object, we need a constructor. But it would help if I didn't misclick. Now, how are we going to contain all the individual sets of nodes that any certain node is adjacent to? Adjacent meaning that it is connected to that node, it points to it. Well, the easiest way is to just use JavaScript mapping. And I like to keep track of the size of my graph. Now we'll go ahead and add some methods. We need to be able to add nodes. It would be helpful if we could get values at certain parts of our graph. We'll also need to be able to delete a node if we're updating our graph, and we'll definitely need to know which nodes are adjacent to one another. Now, these things work with key value pairs, so anything we're looking for, we'll call that a key. And I'm going to use a spread operator to pass in a JavaScript array for all my arguments as to what our key points to. Now, we can use a method that's attached to the JavaScript map object by default called set. With set, we can set key value pairs, and I am going to set our key to the values that we passed in with our spread operator as a set. A set, by default, is going to make it to where there will be no duplicates. And since we put a node in there, we increase the size. All right. Now when we get at, we're looking for the key, and we're going to return a value that we're getting out of our graph using the built-in keyword, the built-in method get. We'll pass in our key, and that's all we actually need to do for that one. And to delete node, we need to tell it what node's going to be deleting, so we need the key. And once again, we can just use a built-in method that's already on mapping, and it will get it at the key. Now we'll go ahead and decrement the size of our graph. And the last thing that we need to put in here is adjacent. So we need to know what we're inspecting, which node we're looking at, and which node we would like to see if it's adjacent to that one. And we can do this using, you guessed it, another method that's already attached to JavaScript's mapping, and we can just tag it at the end of this get method, and this is where we'll pass in the node that we're looking for. Now, if you're like me, you probably want to be able to print out your graph without calling a console log. I just don't like writing all that extra code. So I'm going to make a print function, and it's just going to do a console log of my graph. All right, now we need to create a graph and I'm just going to call it G1 because, again, super creative. We're going to add nodes. I'll just call this one node 1 because why not? Call this 2, this is 3, and I think that's plenty. So now we have this node 1. It maps to node 2 and to node 3. This we can make it map to itself. A lot of finite state machines use that kind of thing. Like in my previous tutorial with exclusive OR as a finite state machine, 0 is mapped back to whatever state it's currently on. Anyway, having just one node is a little boring, so we'll go ahead and add more. We already defined a 2 and a 3 in our previous line, so let's go ahead and create nodes 2 and 3. And, well, we'll make it map back to node 1, we'll make it map to itself, and we'll make it map to node 3. All right, and we'll define our last one here. This is node 3, maps to node 1, maps to node 2. That wasn't supposed to happen. And it maps to node 3. And we're done. We have all of our nodes built in. Now, node 1, node 2, and node 3. Now, I said that node 1 maps back to itself. It also maps over to node 2. And it maps to node 3. So it's connected to all of them. Node 2, likewise, maps back to itself. It maps back to node 1. It maps to node 3. And node 3 maps to node 1, maps to itself, and it maps to node 2. And this is what our graph would look like in picture form. Now, we can go ahead and have a look at our completed map by calling that print function we made earlier. Saving this, and we'll go ahead and run the program now. And there you have it, your completed graph. You can, I guess, ooh, you know what? In the next video, we'll go ahead and create a way of traversing this this graph, and that might be useful for mapping in video games. Actually, you know what? I think we have our first big project. If you like this video, please like and subscribe. I hope to see you again in the future. Have a nice day.